Okay. All right, so here's the idea with reflections, okay? Um, if you have some kind of an object, let's say like this triangle here. Looks like a triangle to me. So if you got this triangle and you want to reflect it, what you need to have is a line of reflection, okay? Kind of like if you were staring in a mirror and you could look at both yourself and your reflection in the mirror at the same time, kind of from the side. So let's say like this is our line of reflection. So to reflect over that line of reflection, then all we need to do is to take every point that's in the figure, and rather than translating it, you figure out how far that point is from the line of reflection, and then go that same distance the other side of it. Okay? So let's say we've got the triangle. This is A, B, C. So if we start with like the point C, how far is point C from that line of reflection? 1 unit over, right? So we'd go to the other side, 1 unit. So there's C prime. Okay, so A, how far is that? 1, 2, 3, 4. Okay, so 1, 2, 3, 4. There's A prime. And B prime, how far is that from the line? 1, 2. So other side of it, 1, 2.
Oh my goodness. That was so hard. I feel
Okay, so one thing to take note of, unlike a translation, the orientation of the image and the pre-image are different this time, right? With a translation, everything was in this, like if you had something going on in like the upper left-hand corner of the pre-image, that same thing was happening in the upper left-hand corner of the image. Everything kind of stayed relative to itself in the same place. In a reflection, that's not the case, right? Everything flips around, so things are looking a little backwards by the time you're done. Okay? However, is a reflection a rigid motion? Is the image and pre-image, are they congruent to each other? Yes, they are. Remember, congruent simply means same shape and size. So is the first triangle and the second triangle the same shape and size? Yeah. So it is a rigid motion. It's just been turned around. Okay? So I'm going to jot that down. Okay, it is a rigid motion because triangle ABC is congruent to triangle A prime, B prime, C prime. Okay, everything still matches up, it's just flipped around there. Okay, so like I said before, with translations, we're going to, just like with translations, we're going to be looking at reflections in a coordinate plane. Okay, so we're going to look at two types, well actually three different types of reflections. Over the x-axis, or a horizontal line, over the y-axis, or vertical line, and then we're going to look at diagonal lines too. Okay, so we're going to start by just looking at what if we do some reflections over the x-axis. So we'll draw just a small coordinate plane here going out to 4 in every direction. Have a few points here. C is at 2, negative 2. And maybe we've got D over here at negative 1, 0. Okay, so let's say I want to take each one of those points, reflect them over the x-axis. Okay, so you can probably just eyeball it and do it. Okay, but I want you to take notice of what the new coordinates are compared to what the old coordinates were. So if B was at 3, 2, and I want to go over the x-axis, okay, so B prime is going to be down here, right? Kind of in the way of C. What are the coordinates of B prime? 3, negative 2. Okay, what if I did the same thing with C? I'd have to come up, right, to here. So there's my C prime. What are the coordinates of C prime? 2, 2. Okay, and so A prime would be 1, 2, 3 down here. What do you notice about the coordinates of A prime? What should those be? Negative 2, negative 3. And what about D? It doesn't move, right? Still negative 1, 0. Okay, so can anybody tell me what's the pattern that's going on with all the coordinates of these points when we reflect it over the x-axis? Yeah.
The y value changes.
Right, the sign on the y value changes to positive, from positive to negative, or vice versa. What about the x? Yeah, stays the same. Okay, so going over the x-axis, no matter what, you've got that pattern happening. Okay, so let's jot that down. The y value changes sign, and the x value stays the same. So that's a reflection over the x-axis. So what do you suppose happens if you reflect over the y-axis instead? Jason? There you go. Okay, if you go over that y-axis, the y value doesn't change, but the x value will change its sign. Okay, so let's write that down over here. All right, so if we're looking at a reflection over the y-axis, the y value stays the same. And the x value changes sign. So the way that I always kind of just memorize these little rules here, I mean, you can draw it and look at it, and it's pretty simple to do. But if you don't want to have to draw it every time, you could just remember, okay, over the x-axis, x stays the same. Over the y-axis, y stays the same. It's the other one that changes. Okay? So let's try a few of these. I'm just going to give you some points, tell you an axis that it's going to be reflected over, and see if you can just quickly give me the answer without having to look at it or draw it or anything like that. Okay? So for each of these, you're going to find the coordinates of the image. Okay, so negative 5, 7 over the x-axis, about 2, negative 1 over the y-axis. Zero 8 over the y-axis. And 5 5 over the x. Alright, take a couple minutes. See if you can do each one of these in your head without looking at a graph. Maybe you're drawing the graph in your head. I don't know. Some people can do that too. But whatever you want to do, see if you can do it in your head. All right, do you guys need more time, or are we okay? It's okay to say yes. We're good? Eh? Okay. All right, so like I said, the trick I remember in my head is whatever the axis is, that one stays the same. So, negative 5, 7 over the x-axis, what should it be?
Negative 5, negative 7.
There you go, negative 5, negative 7. Good. Okay. 2, negative 1 over the y-axis. Yes, Mr. Franken? Negative 2, negative 1. That's over the y-axis, so the y stays the same. The x changes. 0, 8. Somebody else. Yeah, Tara. 0, 8. The y stays the same. The 0 changes sign, but it's 0, so it's still 0. And then 5, 5. Yeah. 5, negative 5. Good. Correct. Yes. So another way to kind of describe that thing here, remember how we did all that mapping business yesterday where I said like X, Y, and then an arrow, and then it goes to something new, right, with the translations, and we did the plus and the minus to X and all that. Well, I can do the same kind of thing here. If I'm going to do, let's say this is over the X-axis. Okay, so remember, over the x-axis, x stays the same, y changes sign. So how could I write it this way, do you suppose? What would it look like if x stays the same and the y changes its sign? We make that into a little formula here. Yep. Right, which would just be negative y, right? So that's another way to describe it. Okay, and they might ask you to do that at some point. So I would write this down if you haven't yet. So over the x-axis, xy goes to x, negative y. And then over the y-axis, it's the same kind of thing. xy. Except this time the x changes sign and y doesn't. So it looks like that. Okay? Now I'm going to caution you a little bit. These two things are just when you're going over those axes, okay? We're going to reflect over a whole bunch of other kinds of lines, not just the axes. So these won't work for other types of reflections, but if it's over an x-axis or a y-axis, you're good. You can use those. Okay? Because what I'm going to do next is a little different. So you might see something like that. Reflect the point 2, 3 over the line y equals negative 1, And then what are the new coordinates of that? Now, some people can do these in their heads too. Okay? If we do this enough and you're feeling comfortable with that, I'm okay with that. But if you're feeling at all uncomfortable, a little unsure, especially if it's a test or a quiz or something, draw the stupid thing out and actually take a look at it, okay? Doesn't matter if it takes you a little extra time. But in any event, so for this one, so we're going to start with the point 2, 3. So 2, 3. So here's our little point. And we're not reflecting over an axis. We're reflecting over the line y equals -1. Well, where's the line y equals -1? Yeah. Exactly. It's a horizontal line at -1. It's down here. So that's the line of reflection. Not the x-axis, not the y-axis, but that line right there. But concept's still the same though, right? You take this point, count down to that line, 1, 2, 3, 4, and then I got to go 4 on the other side of it. 1, 2, 3, 4. So my image is all the way down there. Okay? And what are the coordinates of that new point? Our first point was 2, 3, but where are we at now if I went all the way down that far? 2, -5. Okay? Now, just like going over the x-axis, though, notice how the x-coordinate stays the same? Right? Still 2. However, the y-coordinate didn't just switch signs, right? We had to actually count it out and see how far down it went. Okay? Vertical lines, same kind of a thing. So I'll do one of those with you here too. So if we reflect a point, I don't know, -1, 3 over the line x equals 2. See if I got enough room here. Sort of. I'll count by 2's. Okay, so there's my x-axis, there's my y-axis. So my point -1, 3 is going to be sitting right here. And I want to reflect it over the vertical line, x equals 2. So that's here. Okay, so same thing, right? Just count over. So every box is equal to 2, so how far over am I going to get to that line? 3, so 3 on the other side of it. 1, 2, 3 is right there. And so what are the coordinates of that image then? That's right, 5 what? Yeah? 5, 3. No, it's all right. So again, this time I'm going over a vertical line, kind of like the y-axis. My y value stays the same, but the x changes. But I gotta count it out still though to see where it's at. Okay. So, are we all feeling comfortable? Any vertical, horizontal line reflections? We're okay. Yeah. Okay. Because the next thing is what if that line of reflection is tilted, not just vertical or horizontal? It makes the process a little bit more difficult. Okay. Same concept though. Okay. See how far away from the line of reflection you are. Same amount of distance on the other side of it. Okay, so keep that in mind as we do this. Because while it will get a little more difficult, that's still kind of the basis of what we're doing here. And I won't make these tilted lines terribly difficult for you, and I'll show you how you can kind of get around any difficulties you might have with them. Guys, stop it. Both of you. You're both in the wrong. Okay, so I'm going to draw a triangle DEF. Let's put it maybe down here. Okay, and we're going to reflect this over the line y equals x. Actually, well, I got to put some scale on here first. But can anybody remember what the line y equals x looks like? So, what does that look like? Yeah.
A diagonal line.
Yeah. It goes through the origin, and it's a diagonal line, and its slope is what? 1, right? It's a slope of 1, a y-intercept of 0, so that line of reflection is going to be just like this. Okay? It makes a 45-degree angle with both axes. Does that make sense? So it's like exactly halfway between the axes and straight up. Okay, so now, like we talked about, to reflect this thing, we got to figure out how far each one of these points are to that line of reflection. And it's not just a simple counting it up or counting it to the left or right or whatever. You got to count diagonally towards it, okay? Because I don't know if you've noticed this yet, but as we're making these, like, we're figuring out how far away things are from lines of reflection, we're actually coming at those lines of reflection perpendicular, right? Did you guys notice that? Every time we were counting to a line of reflection, it was always going towards it perpendicular to that line. Same thing here. So I got to figure out, how do I count how far away I am to this line going perpendicular to it? Well, the nice thing is, if I have a slope of 1, and I want to count perpendicular to it, I have to go with a slope of what? -1. Whoever said that, good job. So -1, so I got to count kind of like this. So here's D. So if I'm going to go perpendicular to this line, I got to go like that towards it. You zoom that in a little bit so you can see that. Okay? So see how this line goes through the corners of all those boxes? If I do that but go this way instead, I'm going perpendicular to it. Okay? So instead of counting how many widths or heights of those boxes, just count how many diagonals of those boxes you've done. And it's the same idea then. So to get from D to the line of reflection, I had to go one diagonal box, right? So go one diagonal box through it on the other side. One more diagonal box, boom, there's the reflection. There's my D prime. Okay, so let's try the same thing with E. Okay, so I'm going 1, 2 diagonal boxes to get to the line of reflection. So then 1, 2 onto the other side. Boom, there's E prime. And then F. So this one, I got to go 1. And I'm actually tracing the same line this time, right? 1, 2, 3, 4. So 1, 2, 3, 4. There it is. It's up there. It's not a translation. Nope. It is a reflection still. Okay? And if you turn your page, you might be able to see that reflection a little bit better. If I turn the page like that, do you see how that reflection worked there? Still doing the same thing, right? It's just our reference frame is changed. We've rotated a little bit. but it's still the same idea of how you go about doing it. Yeah.
Is it supposed to be encapsulated every time?
Not every time, but a lot of the time it does. Yeah. So, anywho, so that's how you can pull off one of those reflections. Now, real quick, there is a connection with these coordinates again, though. So what I'm going to do is I'm going to give you the coordinates of D, E, and F, and then you write down the coordinates of D prime, E prime, and F prime, and take a look at them and see if you notice anything that jumps out at you. So D was at 0, negative 2. E is at 5, negative 1. And F is at 7, negative 3. I messed up.
Wouldn't E be at 3, negative 1?
Oh, this is at 5, negative 3. And this is 3. Yeah. It's a 3 and a 5, not a 5 and a 7. Okay. Anywho. D prime, E prime, F prime. Okay, so write down the coordinates of those real quick, and then see if you can figure out what the heck's going on with these coordinates. Oops, somebody figured it out. Gabby? Yeah, X and Y just swap, right? When you go over the line y equals x, they just swap. So if you can remember that rule, you don't have to draw these either. Okay, over the line y equals x, easy. I'm just going to switch them. So let's make a rule for this one too. Anytime you reflect over y equals x, xy should go to what? Yx, right? What? Oh, yeah, we don't have to write it that way, though, if we don't want to. This works for all of it. So every xy becomes yx. They switch, right? Okay, so that's a good way to do that one. Another line they're going to have you reflecting over that is diagonal is the line y equals negative x. Now, I'm not going to do one of those with you because I want you guys to explore that on your own a little bit in your homework, but just so you are set up, ready to go with that, what does the line y equals negative x look like? How is it different from this one? Yeah. Yeah, it goes this way, right? It's got, instead of a positive slope through 0, 0, it's got that negative slope. Still going through the corner of every box as it does its thing here, but it's just going to head off that way. So for that one in your homework, if you come across one of those, I'd like you to actually graph it out. Take a look. There is a little relationship with the coordinates, but I'm going to leave that for you guys to discover on your own what's going on there. Okay. Then the last thing I want to talk about here would be lines of symmetry, which I think you guys have a pretty good intuitive sense. So those at the end of your last assignment where it said, does the figure have a line where you could fold it like a piece of paper and it would fold like right on top of itself? That's a line of symmetry. Okay? So it's basically a line of reflection that you could put through a figure, through the middle of it, so that if you were to reflect it over that line, it would just be the same exact shape when you're done. Okay? Like, for example, let's say I have a square. Now, like a good question that I might put on your test, or you guys might see like on the ACT someday or something like that, is if you have this square, how many lines of reflection does it have? So how many different ways can you fold this thing or reflect this thing onto itself? Yeah, Jason? More than 2. Yeah, Savannah? There are 4. Okay, so can somebody give me one way of doing it? Yes, Kyle? Right down the middle. Okay, we're going to do some dotted lines here for each of these lines of symmetry. So there's a line of symmetry. If I at reflection, it would reflect right onto itself. Good. Okay. Another one. Okay, Savannah. Down the middle, but horizontally. Okay. So there's another one. If I could fold it over that line, it would work. Okay, somebody else, Jen. Okay, and we can go diagonally with it. And yeah. And you can go diagonally the other way too. Yep. Okay. So a square has how many lines of symmetry? 4. Okay. Don't get caught up. Like after you draw it, sometimes you're like, oh, 1, 2, 3, 4, 5, 6, 7, 8. No, there's not 8. Each line all the way through is its own, right? So 1, 2, 3, 4. There's 4 of them. Okay. All right. Let's try. Okay. How about that triangle? How many should that one have? Yeah. Just 1. Yep. All right. Since we're talking triangles, just a second. Since we're talking triangles, what if I had an equilateral triangle? You guys remember what that means? Equilateral is a triangle that has all 3 sides are the same length, all the angles are 60 degrees. How many lines of symmetry would that thing have? Yeah. 3. Yeah, good. Let's see if I can do something a little bit more interesting. It's like a Mario mushroom on its side. Yeah. How many lines of symmetry does that have? Just 1, right? Go ahead and cross it this way. Yeah. So, all right. So you guys get the idea, though. Now, one other one. Oh, you had a question, yeah. Yeah, I was just about to mention that. A circle. Okay, because of the nature of a circle has an infinite number of lines of symmetry. You can always keep chopping it in different ways, and it'll still reflect right back onto itself. Yeah, exactly. So, I'm going to let you guys have at it here. So, here's your assignment. You can if you want to, otherwise just at the top work is fine. You will need graph paper, yep. What? Oh, yeah, that's fine.
She would love it though, Ryan. Thank you. I have to though. I almost needed to yesterday. Oh, you already have one? Yeah, I didn't say it connected, but on my hobby is no, I got it.
Okay, there you go.
That's not that bad.
It's okay.